Alright guys, welcome back to the another video. In this video, I'm going to detect the water bodies from satellite imagery, which is Sentinel-2 imagery. And in order to detect the water bodies from satellite imagery, I'm going to use the Unet deep learning model, and I'm going to use the Google Colab. So let's get started. Alright, so in order to detect the water bodies from satellite imagery, which is Sentinel-2 imagery, the first step is to upload your dataset into the Google Drive. Since I'm using the Google Colab platform, that's why I'm uploading all my dataset into the Google Drive. And here you can see I have xtrain, numpy file, and ytrain, which is the max file corresponding to this xtrain. And also I have the test file xtest, and then I have corresponding ytest file, and the mosaic image xtest.tif and ytest.tif is the mosaic image of the max corresponding to this tif file. So yeah, so there I already uploaded my all the data set inside DL and water bodies folder, and I'm going to use this datalize and utilize the power of Google Colab to train my model and then predict the water bodies. So the first thing is talking about data. So there are like four bands, RGB and NIR band, and then the pixel value is 0 for the non-water bodies thing, and then pixel value 1 represent the water body. So I'll correct this notebook as well. Non-water bodies and then water bodies. Okay, so after that, so the first step is to import the necessary packages. So I'm importing few of the packages: globe, numpy, matplotlib for plotting the result, and also I'm using this tensorflow model input con2d. Like these all parameters are useful for the model. And next step is to connect the Google Drive. So in order to connect the Google Drive, you need to run that cell, and after that it will pop up with the some kind of sign in option, and after that it will be automatically connected. So you can verify whether your Google Drive is connected or not by the left panel over here in the files menu. So if you refresh this list, then you should be able to see the G Drive option. So after that, so since my data set is inside my Google Drive, and then inside my drive, and it's inside DL and water bodies folder, that's why I'm writing this as a child directory. So simply run this cell, and after that I'm going to load my train and test images with NPY format. So simply run this cell. So it might take some time. All right, so it's run successfully. After that, you can see the maximum and minimum value and the data type of your data. The train file, of course you can do the same thing for the test file in order to just to check the the maximum and minimum value and see whether it's normalized data set or not. If the values are between 0 and 1, then it's normalized. Otherwise you need to squeeze it to the 0 and 1. And after that, simply you can test whether your image and labels are matched with or not. So simply since I'm writing 3 index here, that means it's the NIR band, and looks like this portion particularly over here, this is the water body, and over here also this is some kind of water body. And if you are interested to see the RGB image, then you should provide colon 3. That means take the first 3 bands and it will only take the RGB band. And it's quite, I think it's dark here. So yeah, look at this image. So this is the like imagery, and then this is the corresponding marks. That means the yellow part represent the water bodies, and other background purple part represent the background. Okay, so in the next step is to like develop the Unet model. So there are like lots of different kind of like Unet models. I mean, based on their dense level, and then based on the image resolution, image x and y width. So there are like lots of like modified version of Unet, but for this particular video I want to use the very simplest version of Unet, which is like little bit 2 to 3 step depth, and then having size of 256 by 256 image. This image does not represent the exact Unet model of what I'm using, but yeah, this is the like simplest version of Unet. And if you interested to like know about Unet model, there are lots of resources in the YouTube or in the internet. So make sure you like search and then get what's Unet, and try to understand on your own, since I'm not going to like discuss it again in this particular video. And after that, so here in the model part, so I have x in input shape of, sorry, I need to change this, 256 256 by 4. So that means my image x and y width and height are 256 by 256, and the my I have number of band is 4, NIR and RGB band. And after that, there are like some convolution network and dropout, which is useful for regularization. That means it will protect the model from overfitting. And then there is convolution max pooling layer, and then again this first part is encoder, and then the second part is decoder. At the end, so we are using the sigmoid model, sigmoid activation function with the padding is same, and then we compile the model with the mean square error, and then our optimizer is Adam optimizer. And if I run this cell, so it should like take the my updated version of input shape. And then if you see the model summary, so this is the model summary, and then it has only 409k parameters, which is not that much huge parameters. Okay, this step is the like most important step here. So after that, I need to like fit my model. That means I need to train my model based on my training data set, which is train XX and train YY. And also in the validation data set, I need to like provide some kind of data set. But in this particular case, I'm just providing test XX and test YY value is my validation data set. But in the real case scenario, so you should have the 3 set of data set: train, test, and validation. So instead of providing test set, you need to provide the validation data set. That means different set of data over here. And then in the test set, you have like you have to provide the data set which model did not see while training. And then the epochs, number of epochs, I am using 100 epochs for now. And then batch size of 10, maybe I can change it to 8, because normally the batch size should be like multiplication square of 2, either 2 4 8 16 or 32 64, some kind of in that order. And then barbos 1, that means it should not provide lots of information. So yeah, so I can run this. So it says a distribution data set. All right, I just found the issue with the previous code. So the previously I have installed the latest version of TensorFlow. That's why the error persists. And then now I install the TensorFlow with version of 2.12.0, and now my code is working fine. It looks like it's training my model. So we can see the loss and val loss values over here. So yeah, so let's wait till the 100 reports, and then I'll show you the result in a minute. I also want to give you one quick update over here in my model. So previously my loss function was mean square error, and then using that loss function, I saw that my model loss and val loss value was not decreased significantly, and then it was like on the constant value in all the epochs. That's why I changed my loss function to the binary cross entropy, which is the really good loss function. The one really good knowledge about the deep learning model is like based on selection of your loss function, you can significantly improve your accuracy of the model. And of course, instead of using these predefined like loss functions, you can also use the weighted loss function or your custom loss function, based on which the model might get more accurate results. So yeah, so let's wait few times to just to like train my model, and then after that I'll show you the result. All right, so my model training is successful, but now I want to like plot my history loss and val loss function. So if I run this cell, it should like generate the graph representing how my model is trained. So looks like my model like loss function is continuously decreasing, which is good. But when I check the val loss, the based on like test data set, uh, my model was like learning till some point over here might be, because I think this is the lowest value, around 25 epochs, and after that it start increasing. That means my model is overtrained. That means I need to decrease the number of epochs. So in the later video I'll show you how to like train it with train it with the good amount of epochs, and how to control the number of epochs, and also how to increase the accuracy. But for this video, let's say let's assume this model is doing well. So but definitely this model is uh, should do the like predict the water bodies really well in the training data set, but it won't work in the like other data set, like the unseen data set from other places. So if I try to predict the my model accuracy, so let's see how it shows. Yeah, so it looks like it's like doing little bit okay kind of job, but it has lots of like errors. So as I said in the test data set, so this part is the water body, and then it should be like connected, it should be like the river structure, but my model says there is like no connection, and then there is like spread water bodies. And yeah, that's the like limitation of course the data, as well as the model overfitting. So yeah, so but yeah, if I try the same thing with the trend data set, it should like work a relatively good job. So let me try with the trend data set. So trend xx and then maybe trend yy, and if I run this again. All right, so with the like test train data set, so if I like predict the model prediction test on the train.xx, and then threshold of zero point 0.5, and it shows that it has like some kind of like similar pattern with my the training data set. That means it's doing really good job detecting the water bodies in the training data set, but not in the test data set. That's the problem of like overfitting. And in order to solve that overfitting issue, you need to like mention the early stooping function, and then try to train it with the appropriate epochs, number of epochs. And also you can test with the different set of loss functions, and also you can use the data augmentation technique. All right, in the next video I'll show you how to improve the model accuracy and how to train it in the most appropriate number of epochs. So in that way you can like eliminate the overfitting issue, and then your model will predict relatively uh, better accuracy, relatively more accurately. So yeah, I'll see you in the next. In last video we had a problem with our model which has already overtrained, and then it has like limitation of like not performing well in the test data set. So in order to like improve those things, I have makes few changes in this model file, which is water bodies detection version 2 file. And here I have like made few things. So the first thing is like I increased the number of training dataset. Of course, previously we had like 472 images tiles, but this time I had around 1700 images. I like generated the four different images based on the one original image. And then also I shuffle my data set, so this process might also help to like get the more accuracy. And also the definitely in order to avoid the overfitting issue, I have implemented the callback function, early stopping and check pointer. So I'll explain in the video section what this early stopping and check pointer callback function mean. And also I have also tried to implement the weighted loss function or the custom loss function, but I think I haven't I'm not going to show you how to do that in this particular video. Maybe you can try to find the sources in the internet and then try to write your custom loss function, because this the number 4 thing is really varies based on your like task, whatever you are trying to achieve. So based on that you need to like write your custom loss function or the weighted loss function. So let's get started. So the first thing is like I am going to run all the cells as I use in the previous one. So here the in the data pre-processing part, so previously it has like train xx and train yy value, but I rename it to the train xx initial and train yy initial, because I'm going to augment this image with 442 tiles with the like augment it and then get it around 2000 images. So let me run this cell. And for the data augmentation, I'm using the image augmentation library, which is very like helpful and very easy to augment your data and generate the new data based on like horizontal flip or the vertical flip or the like rotation, rotate it with your custom angle, and also with the custom scale. So in custom translation, so x and y translation, so based on these parameters, so you can like do the augmentation both on image and max pair. That's why I have this function. So this is the like sequence. So based on this sequence, I'm like trying to generate the three random images, three random augmented images from that particular image over here. So based on this for loop, so train xx initial dot shape, that means 442 image 0 to 442. I'm getting the image and max, and then I'm mapping both in the same segmentation map on image class. And after that I'm simply looping it with the number of augmentation thing, which is 3. Of course I need 3 images, and then I generate the augmentation image and augmentation max with the my previously defined sequence, and then append it into the augmented image and max class, and then finally I change it to the numpy array so that I can work it easily with in the matrix format. So it might take few seconds to run, and after that in this step, so I concat both my like original initial imagery and the augmented imagery, and initial label with the augmented label, that means max. Okay, so after that I simply append both, and then in order to like avoid the memory issue, ram issue in the Google Colab, I'm simply deleting these two variables. So after that, if I check my train xx max value and minimum value, it's still the same, that means my data is still normalized, and then I have the data type of float 32-bit. And if I check the shape of this train xx and train yy, which is 1762 this time, previously it was 442, but now it's augmented and we have shape of 1768. But definitely if you are like interested to generate the more number of samples, then you can change this number and then you can generate the more samples. Okay, so after that, so based on that the previous discussion over here, so I already augmented my images. Now it's time to shuffle the data. So in order to like shuffle the data, I'm using the numpy array, and then I first of all generate the shuffle indices with the numpy random permutation function, and after that I simply shuffle it with the train xx and train yy variable. And after that, if I hit run, so I can see the image and corresponding their max value. So yeah, this is the like river channel, and then I can see the same river channel over here. But as I said, this max is not accurate, perfectly accurate, because this max is generated from the shape file of water bodies. I don't know the which year or which month this shape file, I mean who get these shape files. But the thing is like I'm just going to show you how to train and improve your accuracy in the deep learning model in case of satellite imagery. But if you want the higher accuracy, I definitely recommend you to like max these water bodies either in Google Earth Pro software or the QGIS or even ArcGIS. All right, so after that I have this kind of Unet structure, and which is quite simple with the input shape of 256 by 256 by 4. And as I said previously, I'm not going to update my loss function, which is over here. So you, of course, if you are interested, then do some research or search with ChatGPT to get the like good loss function. And after that, so here in the model part, so I have also like added the two check pointers callback function. The check pointer first callback function, it will, what it will do is it will try to store the best weights based on the model, and then it will simply like try to determine the based on which value it try to like save the best weight. So here I defined the monitor val loss. So if the val loss is lowest minimum, then it says it's the best weight. So maybe I can remove this part, so it's just the best weight. And then okay, so after that, so in the early stopping function, it's like only like monitoring the val loss, and then it will only stay patient till fifth epoch. And if after the fifth epoch also the value is start increasing, then it will stop like training the model, and then it will simply like stop the model, and then number of epochs, you don't need to go to the full epoch, which is 100. and then that's why I'm implementing early stopping in order to like fit in order to avoid the overfitting issue. And so in the training set I have like train data set, and the validation I have test data set. But as I said previously, this is not the recommended method. You need to like replace this data set with the validation set, and then the test data set should be like the data set which model never seen before. And the batch size I'm still putting 8, and then here I have added the one more like callback function with the callback parameter, callback like these two functions. Okay, so this time our model might take longer time to train it, because previously we had like 442 images, but this time we had 1700 images. So that's why the process is relatively slower. But yeah, it will take some time, and then train the model, and then after that I'll show you the result how it looks like. All right, so now my model training part is successfully complete. As you can see, so after applying this callback function, it says that file loss improved from something to something. So if it's decreasing, it will write the sentence. If not, it says that it did not improve from the latest one. So in the last few reports, you can see in the last 5 reports, the file loss did not improve from 0.7 to 17809. That's why it stopped like training the model after 15 reports. That means within the like 15 reports, within I think 10 reports, we got the like lowest value of file loss, and that's the most appropriate value of this particular task. And based on that, if I try to see the plot, so I can see it over here. So it looks relatively kind of okay, but uh, definitely it's not the great like model. So because it looks like it's somehow like the constant trait, and it doesn't have like uh, much like decreasing pattern. But anyway, so I was just trying to show you how to like train your model and how to improve the accuracy. But yeah, that's the way. So after that, so based for the prediction, so you have to like import the load model function from tensorflow keras.model, and then load the best model dot s5, or sorry, I forgot the name. Best weight, it should be best weight. Okay, best weight dot s5. So it should be stored somewhere here, so in the drive. So you can see best weight dot s5. So that's the model we are getting here. And then after that, if you try to like predict it with the 0.5% threshold, it should like predict the model. All right, so this is our prediction, and this is our original like label, so which looks like kind of okay. And if I try this with the test data set, test xx, and then maybe test xx, test yy, since it's the y value, and I can also like see the result. But definitely this is not the great model, so it's here. So in the test set, it's still not performing well, so we can clearly see that over here. So yeah, but somehow it has relatively like good shape to in order to like in comparison to the previous model. So the river was over here, and then it's kind of like predicting relatively like a good way, and also the river was here, and then it's kind of like predicting in the small shape. So yeah, that's why the data augmentation and then the early stopping is necessary in the model development. So I hope you are also like able to improve your model with these techniques, And if this video is helpful, then hit the like button and subscribe to my channel. Thank you for watching, and I'll see you in the next. Alright guys, in last section I have showed you how to predict your test data set, and then the result look little bit nicer compared to previous one, but still it's not the best result. And in this video I'm going to show you how to do the accuracy assessment in our model. So let's get started. So in order to do the accuracy assessment in the image segmentation tasks, there are four most popular matrices that we need to take care. The first one is precision, and second is recall. Similarly, third is Yapon score, and then fourth is intersection over union. So in this particular section, so I'll talk about these four matrices, and then I'll try to see the accuracy of my model. All right, so before explaining these accuracy metrics, I want to discuss about this table, which is also known as confusion matrix. So here, if we plot our actual value in the x-axis and then the predicted values in the y-axis, then we might get the four different categories. One is true positive, false negative, and true negative. So that means if there is actual water bodies in the ground and then we predicted it as the water bodies, then it's called true positive case. But if there is actually water in the ground and then but we predicted it as a non-water body, then it called false negative. And similarly for the false positive, if there is no water on the ground, I mean no water in the image, but we predicted it as a water, then it's false positive case. But similarly, if there is no water in the image and then we predicted it as a non-water body, then it's the true negative case. So those are the four different kind of actual value and predicted value case scenarios, and based on these cases, so we'll simply calculate these matrices. So the first matrix is the accuracy, which is true positive plus true negative by true positive, true negative, false positive, and false negative. That means our true case scenario divided by whole case scenario. But in case of image segmentation, in order to detect the small amount of object in the image, so the accuracy might not be relevant because it deal with the the denominator will be much larger than the denominator. Then we end up with maybe good accuracy, because we also have the true negative, also the non-water body is also really high in the image, and then we might end up with the high accuracy. But that's why the accuracy matrix is not that great in case of small object detection in the image segmentation tasks. Talking about precision, so which is true positive divided by true positive plus false positive case. And then similarly for the recall, true positive divided by true positive plus true negative case. And F1 score is the 2 multiplied by precision into recall divided by precision plus recall. But in most of the case, if our accuracy is near 1, then we call it higher accuracy, and if it's near 0, then it's low accuracy. And most of the time we only depend on the F1 score. And yeah, so here so I have this converted my actual ground truth, which is test YY, which is the water bodies in the image, into the I converted it into the unsigned integer 8-bit. And then similarly for the predicted one, I converted it into the unsigned integer 8-bit. And after that, so I wrote a function to calculate these matrices. First of all, I make these both ground truth and then the predicted mask into the 1D array, and then based on that I simply calculated true positive, false negative, and true negative case. So as I explained before, so these are the like cases. It should be, for example, for the true positive, if the ground truth is 1 and the predicted max is 1, then we call it true positive. And similarly, we call it false positive, false negative, and true negative case. And based on that we calculate the precision, recall, and F1 score, as I showed you previously in this formula. So I'm simply applying that formula, and then I also apply intersection over union, which is the like case of true positive divided by true positive plus false negative. And yeah, based on that, simply I return the precision, recall, F1 score, and IOU value. And if I hit run this cell, so it will simply calculate the like precision, recall, F1 score, and IOE based on our test data set, test YY, and predicted test. And the accuracy is like for the precision we have like 77% accurate, and recall is quite low, 46%, and F1 score is 58%, which is kind of okay in comparison to like our scenario, because the actual water body was not there, because in our sample we use the predefined shapefile. In shapefile we don't have like exact boundary of the water bodies, that's why. But it's also kind of okay accuracy. And for the intersection over union, it's 41%, and which is relatively kind of okay. And yeah, so yeah, that's how you like calculate the accuracy, do the accuracy assessment. So I hope you enjoyed this video. So I'll see you in the next. I think this is the most awaited section from the deep learning course. Lots of people ask me to create the tutorial how to merge the tiles after predicting from deep learning model. So in order to do that, I'm going to use the GeoTile package, which is over here. So this package is available freely on the GitHub under my profile. Its name is GeoTile. And if you like the code and workflow, please hit the star button. That means a lot to me. Let's go back to the code. So here, so first thing is you need to like import this package. So simply run it uh, and then install it, and then after that you can import it with the from GeoTile, import GeoTile. And after that you need to like initialize this package with your large image, and based on that you can simply like predict uh, all the like tiles, and then you can like merge them back and then get the single image. So here I already uploaded my file xtest.tif in the Google Drive in the same location as DL water bodies, and I'm going to use the same file to predict the deep learning like water bodies. So here you can see the width and height are quite different than the our model input, which is 256 by 256. So but I'll show you how to like predict and save it as a single file. Okay, so the first thing is to generate the tiles. Of course we can generate the tile and then save it internally with the save tiles equal to false option. And then I also try to provide the stride x and y value, because this time it's just the prediction and we don't need the overlapping of the image. Of course if you want you can provide like leave it as a default option, which is 128 by 128, but I recommend you to like not to provide the overlapping area. And after that, of course, as I showed you in the previous section, so we need to pre-process the data, which is convert none to zero, and then also normalize the tile. That will normalize our tile values between 0 and 1. And after that, if you check the some of the parameters, so tile data dot shape, there are 70 tiles it can produce, and which are like 256 by 256 by 4 size, which is exactly same as the model deep learning model input tiles shape. And then the maximum and minimum value is 1 and 0, and then data type is fluid 32. And after that, you can like predict your test model.predict based on the gt.tile data. But this time I think I forgot to initialize my model over here, so let me go back. Okay, I need to run this cell, so it will load my model. After that only I can do the prediction. So after that, I am simply doing model.predict on my gt.tile data. So the tile data shape is over here, so it will try to predict. And then if the prediction is greater than my threshold value, which is 0.5, then I call it as a water. Otherwise I ignore it. I say it's just the background. So after that, so my prediction is done. After that, I need to add that prediction on the tile data attribute. And yeah, so after that I can save my tiles into the prediction tiles folder. So you can say whatever folder you want, so it will just save the TIFF files into the one particular directory. Okay, so it might take some time. And after that, the next step, which is the final step, is to mosaic those tiles using mosaic function. So in the mosaic function, we have to provide the location to achieve that tiles, and then the output name of that tiles. So you might, if I do the refreshing over here, you will get the predicted tiles over here. So these are the tiles, predicted tiles automatically generated from GeoTile package. And after that, so I'm simply mosaicing those tiles into the predict merge.tiff file. And if I check over here, I should get that predict merge.tiff. So it should be inside water bodies, and then here it is. Okay, so this is the required file, so I can download it, and then I can visualize it in the QGIS. Or if you want, you can visualize it with the matplotlib package as well, but I prefer to visualize it with the QGIS. So which is over here in the download folder. So predict merge, and then okay, so these are the predicted water bodies from our model. So yeah, which is quite nice. But the one thing is if you notice it here, so these are the not the water bodies, these are the sands. And then it pretend the sand is also the water body, because in the training set also we don't have the clear boundary of water bodies. And then I think we provide the sand as the water bodies. That's why based on our model training, it learn how to separate the water bodies from satellite imagery. But in this particular parts, you can see there are lots of noise, so these are not the water bodies in our y true value. So let me load that file also. All right, so this is the actual like level from our training data set, and then this is the like predicted one. So predicted one has like less, I think, narrow boundary of the water, but in the actual white test we have like very thick border. And yeah, it looks like it is like it predict really well. It did detecting the water body, good job. But as I said before, it's not the like actually good model to detect the water bodies, because even in the training data set we have like classified the sand as a water body. That's why our model is like predicting sand as a water body. But anyway, so the overall concept of this video was to like introduce yourself, how to train your deep learning model from scratch, how to prepare the data set. So I hope you got the idea. So I hope you enjoyed this video. If you enjoyed it, hit the like button and subscribe to my channel. Thank you for watching.